All right, so now we're looking at polynomials of degree at most 3. So at most, so a naught plus a1t plus a2t squared plus a sub 3t cubed. Okay, so it's also got the added criteria. These coefficients have to be integers. So all the AIs have to be elements of z or integers. Z is another way of saying integers, right? And integers are 1, 2, 3, -1, -2, right? Things like that. Okay. So I'm going to go right to the one that I know is not going to work. So the criteria number 3 for the scalar c, and the scalar c, remember this means in, the scalar c in the real numbers, right? If I take c times p, this will give me ca0 plus ca1t plus ca2t squared plus ca3t cubed. And these coefficients are no longer no longer have to be integers, because my c is a real number. So no, I shouldn't say no longer have to be integers. My c could be a real number like pi, right? Or e. And so then pi times a constant, or pi times an integer, is no longer an integer. So this is not a subspace. All right, so now let's look at vectors of this form. So polynomials that look like this, so these are what our vectors are. Even though they're polynomials, we call them vectors in the subspace. So I'm determining if these are going to be a subspace. So a and b are in real numbers, and t is real, but remember, you never fix t. Okay, so let's first see if there is a 0 vector. Well, I can let a and b equal 0, so that gives me p of t equaling the 0 vector. So I'm good. Yes, check. How about if I have 2 vectors in the space, so p of t equal a plus bt squared, and q of t equals c plus dt squared. If I add the p and the q, and I really should be putting hats on the p's and the q's because they're bold when I print them here, that means they're vectors. So a plus bt squared plus c plus dt squared gives me a plus c plus b plus dt squared. This is in the subspace. That fits the criteria of what the elements look like to be in the subspace. So check, it's closed under addition. Therefore, closed under addition. I want you to get used to that phrase. Okay, so for the third criteria, for this p of t, if I take and multiply it by a constant c, so c times a plus bt squared gives me c times a plus z times bt squared. That is in the subspace. It still fits the criteria of what the items need to look like to be in the subspace, so check. So therefore, this is a subspace. So this, I should say, this is closed under scalar multiplication. Okay, so let me stop there and I'll do the next ones.